Hello! Back a little while ago, I think over a year ago now, I did some introduction videos on OpenIPC. And at the time, setting up OpenIPC was quite complicated to the point that my second video about how to do the setup was about 1 hour 15 and basically had to have, here's a quick introduction to how to use Linux, and I still had to send you off to learn how to use Vi and stuff like that. I was aiming to come back to it, always do, and I never have the time, and then I'm flitting around doing different things, and I'm thinking, oh, I've got to get back to it. And then what happens? One of the leading camera manufacturers actually picks up the idea of using the project in one of their products. And that company is RunCam, and they have made this. This is an all-in-one camera and VTX unit that runs OpenIPC, and it looks like this. It's a fairly chunky boy. Basically what it's got here, this bottom board's for the camera, this top board is the Wi-Fi, and that bit on top, it keeps the Wi-Fi cool because they run quite hot. What's pretty amazing about this is they are selling this. I don't like to talk about prices, but pretty much as cheap as you could possibly do it. $69.99 in dollars, which is cheaper than I think OpenIPC's own offering called the Mario All-in-One. RunCam, of course, have the power to do things in bulk, and that can bring the price down. Not only have they done this, they've also come up with an option called the WifiLink G, where they give receiving hardware, which is in this pack here. And what you essentially get there is this. This is an AC 1200 wireless USB adapter. You've got 2 antennas for that, 1 on each side. And they also give you this. This is USB-C to USB. The idea being that you plug that in and this goes into something like an Android tablet and you watch your stuff from there, which is all really interesting. Now, I haven't touched OpenIPC for a little while, and I want to see if there were some differences when I last used it, and RunCam have brought some of their own stuff to the table, so I think what we need to do is go into close-up, see what we get there, see how it all connects together, and let's put something together and get a config done. Alright, so let's have a little bit more of a closer look about what we get inside this thing. Here's the main unit. It's got a little camera. I think this is 19mm, so quite small but very mountable. Nothing weird or big about that. And then there's this unit here, which the camera part and the Wi-Fi part and the great big fan that's going to take the heat away. What else we got in the box? So shop RunCam, that sort of thing. And then in here we've got some cables. We've got some standoffs and some screws. We've got a wire to connect it. We've got some antennas to plug in. This JST to Ethernet, I guess, to set it up on the computer. I'll double check it, but it says RJ45 there, so I presume that way. And then we need to connect it to our flight controller, and we've got these 2 UFL connectors. If you look carefully under here, you'll see 2 UFL connectors, so let me just put those on, which clip in pretty simply like that. I think that's how it's done. We'll just have a quick look at what's in this bag when we're here. I've gone through it. Take this bit off. Antennas on, and that is ready to go in an Android tablet. Right, so how do we set this guy up? Don't know. Let's check the documentation and find out. This is the documentation that RunCam provide, and I thought I'd just look at it because it's a little bit, not as confusing as such, but it doesn't necessarily tell you everything you want to know in the correct order. We've got a lot about how it's built, that's fine. There's actually a slot here. This is for putting an SD card in, but it's reversed. So instead of the SD card going in from the outside, you have to remove the top board to put the SD card in that way. And I'll explain why that was relevant later. And installation, it's basically saying you need to have these metal things connected to this board in order to help dissipate the heat. This board actually gets pretty hot. The Wi-Fi board is the one that's cooling, but this does run quite hot. You really do need some airflow going over it if you can. It talks about the 4-pin cable connection, which is fairly important because these cables are kind of reversed, so you need to make sure that your voltage is over on the right hand side there when connecting. This one, it would be in the wrong side, and that would be bad. It's actually set up as default to have 1080p 60 frames per second, which is fine, but it's not the lowest latency thing you'll get. And you can see that great for power, 3S to 6S, so you can go straight in there and it will handle it. So it says it requires no configuration, simply follow the steps. It's going to talk about these keys. The keys are important. Basically, on the ground station, there is a ground station key. On the drone side or the air side, there's a drone key. Normally, you'd generate these from the ground station, and then you'd put that ground station key in the relevant place, and then you'd move the drone key over to the air side. On this, it talks about the FPV View app, which is great. You can get hold of that and basically sideload it on your Android phone or tablet. And that will have a ground station key that it uses by default. Should it work straight away with the Wi-Fi link? It seems to suggest that way. I was unable to test that because I had some other issues which I'll come to. But I kind of generated my own keys. I'll go through about that one in a sec. And then it's got set parameters. It sets the video to 173. I'm going to use channel 161, which is 5805 because it's right in the middle of the 5.8 band. I thought that was quite useful. And then it's got, this is what I mean about out of order, it's got how to obtain Wi-Fi keys and configuration files, where it says insert an empty SD card into the camera, power it on, and the camera will generate the required config files. And then presumably you can use that. And it's got different bits about how to change parts of the camera. We'll come to that a bit later. It's also got this bit about how to use the Ethernet port and gives you this IP address, which I found is not the case, because what it will do is it will use DHCP, and so it's going to vary what address you get there depending on what you have on your network. For example, some people have a 192.168.1 network, some might have a 192.168.0, or you might have a completely different address on your own network. So that's something to bear in mind. And then it talks about, again, the importance of the GS key, and it says WifiLink is paired with FPV View app by default. In theory, I think it's telling you should be able to use it. If not, I will be talking about how I generated and got my key and do it that way. And then it's got an actual PC ground station, which I haven't checked because it is Windows only, and I didn't think I'd be running this from a laptop, frankly. It also talks about what other ground station compatible, computer and RAXA 03W. I've also got the one called the NVM, which is a very cheap little ground station, so I'll be showing how to use with that. Finally, it talks about like if you've got no flight controller OSD information on the screen. I found yet another problem there with Betaflight, so I'll go through that. So let's talk about exactly what I did to get this thing configured. So I will give you the very short version of what happened and why I couldn't get this thing running. Basically, I just expect it to work. So I turned on my tablet, I plugged in the adapter, and I couldn't get a picture. So I thought, oh, it's probably the ground station key thing. So I know what I'll do is I'll take my keys that I know work from here, and I'll pop that across on the camera. And I can do this via like SCP and SSH, no problem. I'll talk about a different config method in a moment, but still wasn't working. And I was trying everything. I was trying back with my original camera and my original ground station. That all seemed to be fine, and I couldn't figure it out. And I talked to Mario, who does an awful lot with OpenIPC, and he suggested we had a video call and go through it. And we went through and we started again from scratch, and everything seemed to be fine. And he was sort of saying, it sounds like your Wi-Fi card's dead, because it wasn't running up this process called WFB, and to do that it needs to detect the Wi-Fi card. And out of some desperation, he suggested, well, go back and do the original thing it said about putting the SD card in and seeing if that works. And I'll just show you how you'd actually do that if you wanted to, because it involves basically unscrewing these two screws, and then what you've got there is this little slot, and what you would do is pop an SD card in like that. And this is the smallest SD card I've got. This is out of an old phone. It's a 256 meg card, but the file it generates, the GS key, is absolutely tiny, so it's no big deal. Anyway, we did that. I put the top back on, which I'll do now, and I powered that on. I then powered it off, took the SD card on, and I put it back together. And I just had the SD card in the computer to try and find out what's happening. And I noticed I had a picture from this thing. It suddenly started working. So what was happening? And we figured it must be the connections. So I was putting around these, nothing happened, and I prodded, and I got the image to freeze. So I figured it was this connector, which looked absolutely fine, and I unplugged it, I checked all the seating of the pins, I plugged it back in. Since that time, it's been absolutely fine. The reason I mention this is just in case this happens to you, check this out. Try taking it apart, check your cables are free, make sure that's in good, check all the pins are in nicely, and that might help you out. So at this point I'd kind of wiped out the original configuration and put my own ground station key in. So what might happen is you turn this on, you plug this into your Android thing, and it might work. If it doesn't work though, here's what you can do. First off, it sounded weird to me, but apparently you can use the drone key on the ground station. Now I thought this would be a sort of private public key pairing, but apparently they're not, and you can use either. So if you go onto here, you can get the drone key and then move it over to your tablet and call it the GS key and then use that. So how do you get that off? Well, there's two methods. If you're comfortable with Linux commands, or not so much Linux, just like SCPing and stuff, you can SCP the file directly off there and then move it onto your tablet. If you're less comfortable with that and you're a Windows user, you have this new thing called the OpenIPC configurator, which I'll show you next. Okay, thinking about it, there's actually 3 ways of getting the GS key off. One of which is to put the SD card in and power it on, and then take it out, and you will have the GS.key on your memory card. Alternatively, what you need to do is power this up and plug it in something. I've plugged this in this is called an Orbi, it's like part of a mesh network. That's my general router. But the question of how you find what address it's on, because despite what the manual says, it doesn't necessarily come up on that address. Usually, when you've got a wired network like this, or a wired connection, you will be able to log into one of these things and say what is logged into me and what address is it on. And if I do this on my phone, now this is going to vary depending on what you have on your sort of network stuff. Most internet providers will give you a log on to the router so you can check. What I've got here is all my online devices, and under all this I've got wired, which says OpenIPC SSC, and if we look at that, I will see I'm on the address 192.168.1.87. So if I want to do things the traditional way, I can SSH over to that. The password is 12345, and it's ready-made with OpenIPC. If we go to etc, you'll see there we have the drone key, and we would just grab that. Also in here, we can do things like change the channel. As you see there, I've changed it to 161. And if we edit majestic .yaml, that's where we can change things like our video. So we've got the codec as H.265, the frame of 120, and the size of 1280 by 720. That is, as I said, by default on 1080p 60. Oops. Anyway, if you wanted to grab that key, you would just say SCP router 192 etc drone.key, and we can grab it as gs.key. So there you see, we've basically got that as a gs.key, and then we could put that onto our tablet. So the other method, as I said, is using this new little app called OpenIPC Configurator. Okay, I'm a little unpracticed with this because this is running as a Windows 10 virtual machine, but basically you put the same thing in. So I've got my same address, I've got my password, and that's the default SOC, which I think is fine. So I hit fetch, and it goes and does some stuff in the command window, and then I hit read, and then it finds out we're on channel 161. And if we look at the camera settings, that we're at 1280 by 720, and frames are 120. So what you can do is you can change this from this menu, and you can go ahead and save that and then restart Majestic, and that will do it for you. Also in this bit you can go up to the setup. Now I actually thought on this bit we should be able to receive the drone key, but this is set up to do it on a ground station. Normally you would generate your keys on the ground station in the root directory and then you'd move them around, and we don't have the generate keys bit because this isn't a ground station. And if we were to click on receive drone key, basically it tries to get it from root drone key instead of etc drone key, which is where it lives at the moment, which is an interesting issue. Although I do notice this bit about it can scan your subnets to see if it can figure out what you are. So if you don't know your IP address, it tries to figure out available IP addresses. Basically it's just going through and pinging things by the looks of it. Yeah, so what it looks like it's doing here is establishing if any of these IP addresses are alive, and then gives you a list of things to try. So, you know, you could trial and error it by doing this and then putting all these in. You see 87's there, but that would take you a while. So if you can just log into your router and check it that way, that would be more simple. But it does look like this could do with a change, so you can opt to receive the drone key from the actual camera itself. Again, it's because it's not a normal thing, because the key generation happens on the VRX, this doesn't seem set for that. So I guess because this doesn't seem to work, I can't see any different way I can change it to get it. I just thought this would work. It looks like you do in fact have to either get that GS key or drone key either by putting the SD card in or by using SCP. But this is seemingly a fairly good application for changing bits of your camera and your channels and things like that. So once you've got the key off there and you move it to your tablet, which may be a various thing, and I've got this little application I use on this Huawei tablet, or there's, you know, other ways of getting it on there. You can send it to yourself, generally something that you can drop a file in. What you can do then is check it out. Now I actually did a little bit more editing on this one, because after I talked to Mario about the best latency you can expect from this, he said one of the things to do is not to use it as 1080, but on a tablet try 720 at 120 frames per second. So I changed the settings that the camera puts out and did it that way. So what I'll do is turn some stuff on. So this is, there's a lot of fingerprints. This is the application called FPV View. It is in the links on the RunCam documentation. I've added little bits of OSD things here, and what you can do is change your channel this way. I've changed my channel to 161. You've got codec there. It was on 265 by default, which is correct, and you can add and move OSD elements about with that bit. And you've got a recording bit as well. Here is the bit where you would go and drop your GS key in there. If I click on this, it will then open a file browser basically, and then you select the GS key that you've got. In theory it should all work. So if I pop that there and plug a battery in here, what I've got here is an ESC stack and a F7 flight controller, which is then linked to here. And I think we're using basically a straight voltage out, and it will take about 20 seconds or so, and then we should get a picture established, which we've got there. And you can see my hands there, and you can sort of get the grips for what the latency is. Now if we look at the screen, I have actually put the latency thing on. So at the moment it is saying it's getting what, 109, 112 frames per second at 720 with a latency of about 36 milliseconds. Now on an Android tablet, what have we got? Channel on. There we get that bit out of the way. On an Android tablet, it's going to vary massively about your performance, because of course it depends very much on what the processor is like and how well it can decode the H.265 and stuff. But as you see, it's a fairly good thing here. Now you're probably wondering, well, that's great, but I can't fly having this in front of my face. Or perhaps you can, it depends on you. So is there something you can do to also get the feed into your goggles at the same time? The answer is yes, through a fairly simple solution. And that is a little USB hub. You might have one of these on your computer, especially if you've got no traditional USBs and just have USB-C. So this would get you some USB-A type slots, as well as some memory cards and an HDMI out. If we plug this in, I've got a TV just in the background here, which is terrible, but works. Okay, so now what we've got is the same config here. We've got our tablet, and coming out of the tablet we've got that USB-C hub, and you'll notice the HDMI is going out. We've still got the Wi-Fi adapter in there, and this is connected to this TV, which is a broken one. We should go in the bin. That vertical line there is why it's broken. But again, if I tap my hands in front of the camera, you can see that we've got something. Of course, I'm not suggesting that you use a TV screen to fly around it. That'd be even worse than trying to hold a tablet there. But what you should have on many goggles is an HDMI in. So this is representing your goggles. So you can basically take the HDMI from this adapter, run it into your goggles, and be able to record via either Android screen capture, or there is actually a record setting in the FPV View application. So that's how I would use that. Now that is set to currently use 120 frames per second at 720p. If you had something a bit older, like this little fella, this is my NVR. It was only about £11 from AliExpress, as well as this sort of couple of quid Wi-Fi adapter. That can only do 60 frames per second, but should work. This had the original GS dot key and drone key, so if I plug this in and have this camera run it, it should work. Obviously I'm going to borrow the HDMI from this thing and use it that way. Okay, so this time we've still got the original flight controller, the RunCam product, the little camera doing its thing. I've still got the tablet linked up to the Wi-Fi adapter, but not to the TV. And then I've got the NVR here, which does have the HDMI out to the TV. Over this bit we've got the little Wi-Fi adapter, which gets hot, so we've got a fan running on it. And if we look up at the TV, we have got the output there. And there's my fingers. So this sort of config made me think that instead of using this thing, which gets a little bit hot and bothered, can I just plug that into my old NVR? Well, let's try it. Okay, so this time we've got the flight controller, we've got the OpenIPC camera, and we've got the NVR here with the Wi-Fi adapter in it. And if we look up on the screen, yeah, it works. We do indeed get a picture. And the best way of using an external NVR thing like this is apparently the Raxa 3W, which has the best performance in terms of latency. But that is the general thing of how it all works. Now you're probably wondering why we haven't got anything on the screen here about stuff, and let me just flick over to the tablet again to show you this. And the reason I'm just using the tablet here is basically I can put everything in frame. It's not better or worse than the other one. But you will notice that we've got stuff like a voltage. That should be the battery. That's the flight mode. And then I've got degrees here, and that's my roll. And if I do stuff with it, it's not working. Why isn't it working? I spent more hours looking at this and wondering, like, what the hell is the problem? And it seems to be Betaflight. I have got here the TX2 connected up to the RX of this, and I've set this up to speak WifiLink telemetry, which is what OpenIPC uses to generate the OSD, and we're getting nothing. And when I looked into it a bit more, I couldn't see anything coming out of that port, and I thought, is there a problem? But no, it appears to be a problem in Betaflight 4.5. So just having a Google to see if anybody else had had issues with WifiLink telemetry, I found this bug where the suggestion is that nothing is coming out of the UART if you set it up. And if you read through, it generally does say that, you know, not many people are using WifiLink, so it's possibly a case of the code hasn't been looked at for a while. There was a suggestion to add the telemetry WifiLink as a custom option, which I did try, but doesn't seem to have worked. Now that was actually closed off because the originator has a workaround using MSP for it, but that didn't work for me. So I have added something to that and asked it to be reopened, or if there's a workaround available that it's talked about. So we'll have to see what happens on that. And I know WifiLink used to work on Betaflight because I have used it before on previous OpenIPC. I used Betaflight on a flight controller to get stuff. So hopefully this should be fixed at some point. But even if it's not fixed, this is a video from TipoMan and shows OpenIPC working with the standard OSD via MSP DisplayPort, which is supported in iNav and Ardu and Betaflight, and works exactly the same as WalkSnail and DJI. The difference is that the actual camera is rendering the fonts, and in this case it was a test of using the AHI differently and rendering it yourself, which is very good unless the signal's bad, and then all your OSD also loses it a bit. But I think it looks pretty good, so look out for that one because I think that's just about finished and should be dropping in the codebase soon. So there you go, that's the video for now. I'm not going to put it on a quad on this video for two reasons. For one, this video is almost half an hour long already, which is quite long for something that should be fairly simple, but I did have some issues and I wanted to give a complete picture of how it works. Secondly, I can't use my field until September because there's an event going on in the field over which I fly, and I don't want to risk having it dropping on people's heads. And the other farm don't want me flying there while that's happening, and obviously I want to keep them sweet because when they don't have that event on, I'm good to do anything. So this is already quite an improvement over what I had before, which the equivalent looks like this, which was really too big to fit in a quad and had a load of different power regulators and quite weird Wi-Fi. This is going to be a challenge just because of the size of that fan. It's been suggested that enough airflow would cool this, but I thought I'll have it set up as is for the first time and we'll see how that goes. And I want to put that straight onto a quad and see how it goes. There is not an awful lot of difference between these. Obviously the power regulation's much better. You can just plug anything from 3 to 6S in and you go, as opposed to having all these stupid adapters to try and do it. But the size of the camera is fantastic now and it's a really good quality picture. The big difference in this is that I had to find the flashing pins and flash it and then set it up, and that was difficult. Those of you that watched the video about that and didn't have sort of, you know, regular Linux knowledge and didn't want to be that involved, I can imagine you guys saw how this was made and said, no, this is not for me. This is a lot more simple. It's not as simple as just setting up an analog camera, but it's so much more easier because that flashing has been done for you. You've already got OpenIPC on it. It is just a case of setting some stuff up, most of which you can do from that Windows app, so you don't even have to think about SSHing around. It's just a case of getting that key in place, and how that works is the only vaguely tough bit. This thing worked really quite well as well. I think it's really worth getting this pack just for a simple way of receiving data, because without this you're going to have to make your own ground station, and with this I could use it with my original ground station, or I could use an Android tablet, and you saw how I used that USB-C hub, and I could plug HDMI right into my goggles that way. So some good options there. As far as features, I know that currently OpenIPC are working on making their own goggles, because you have to think about, oh, how am I going to get this to my goggles? I need basically an HDMI cable, and then I'm tethered and I have to be careful about that. So they're working on that. I also know they're working on something equivalent to focus mode. So you'll be familiar if you fly DJI or Walks now, that you can have it so the size will pixelate and try and prioritize the stuff in the middle. They're looking at something similar to that. So interesting things on the horizon. So come September, I will be fitting this in a quad. I think I've got one picked out. I may have to extend it upwards slightly with some risers to fit it in. And yeah, we'll give it a try and see what happens. Until that time, I hope that's been helpful. Any questions, please pop them down below. And any corrections, like for example, if you've got MavLink working out of a UART on Betaflight 4.5, then please tell me how. I'd love to know. And I will catch you next one. Bye for now.
Well, you've made it to the end of the video, so thanks once again for watching. If you like what you saw, then please consider subscribing, and if you really like what you saw, then be sure to check out the link to my blog for a variety of ways in which you can help support this channel.